Hello.
Yes.
Okay. I think I see a few people have joined. So, good evening. Today I'll be solving a few problems based on week 2 lectures. I'll wait for a couple of more minutes to let others join and then we'll start. Meanwhile, please let me know if you can see my screen and hear my voice.
Yes, ma'am.
Okay.
Visible
Yeah.
and audible also.
Thank you.
Yes, ma'am, it's visible.
Okay. So, before I begin the course, before solving the problems, do you have any doubts with respect to week 1 lectures or the week 1 problem solving sessions? Anything you would like to discuss?
Yes, ma'am, I have a doubt.
Yes.
Ma'am, there was a assignment in week one.
Hmm.
There was a question. 1 second. Yes. Ma'am, I can't solve the problem number 6. Use Bowley's measure of skewness for following distribution of week one.
Week 1. Okay. Okay. So the solution is available. Did you have a chance to go through the solution?
Ma'am, it's not opening in my app.
Okay. Okay. So I'll just. Can you see week 1 slides now?
No, ma'am, it's showing week two.
It's showing week 2. Okay, I'll just stop and share. 1 second. You can see week 1, right? So from the table that is given in week 1, you just have to find out these q1, q2 and q3 using these formulas and then
Mhm.
substitute and get the Bowley's measure of skewness. So this one I already explained last week. Please give it a try. If you can't, then post it in the discussion forum. I'll send the solution.
Okay, ma'am.
Okay. So this is the
Yes, ma'am.
formula that you should be applying to get Q1, Q2 and Q3. And once you get Q1, Q2, Q3, the Bowley's measure calculation is fairly easy.
Okay, ma'am.
Okay. I would suggest just give it a try.
Okay, ma'am.
Okay. So now I'll just share week 2 lectures and I think we can start now. Yeah. All right. So in week 2, we had discussions related to what we mean by a random variable and its types. It could be discrete and it could be continuous. So discrete variables were those variables where the observations were countable, uh, the values, they were countable number of possible integer values. And if it's continuous, then it can take, the variable can take on infinitely many values on a continuous scale. So as an example, we gave this one like number of heads in a toss in 10 tosses, let's say. So it can take finitely countable number of values like 0, 1, 2 up to 10. This could be the values of x. Or it could, this is finite, it could also be countably infinite, like number of accidents on road, let's say. So it could be 0, 1, 2, and there's no end to it. It could go until infinity. So those kind of variables are discrete And continuous, like we gave examples of height, weight, prices, and so on and so forth. And it was discussed what we mean by a probability mass function, which is probability mass function, we should be very careful, is associated with a discrete random variable. Okay, mass function is always associated with a discrete random variable. So what it is actually the probability that the random variable x takes on the value small x. So here notation will be followed uniformly. If I have capital, then I denote a random variable, and small x would denote an
The
observation
value.
on the, yes, the values, or simply put, values. So this will be followed uniformly throughout. So here a probability mass function is nothing but the random variable capital X takes on a value small x, and that is denoted by pi over here. And there are a few properties to pi. Probability should range between 0 and 1, and the sum of all probabilities should be 1. And also another concept was discussed of a cumulative distribution function of, or a CDF, which is nothing but probability. It's cumulative. So probability, the random variable can take on any values up to the small x, the observed small x. Also it was discussed how we can calculate, or the formulas rather, to get the summary measures of mean, median, variance. And as an example of discrete random variable, these are examples of discrete random variables, binomial and Poisson distribution was discussed. And also it was discussed how we should calculate the mean or expectation of a random variable. Okay, so the expectation of x is nothing but summation of the value into its associated probability. And also everything in this slide is with respect to a discrete random variable. And for a median, if m is the median, then probability x greater than equal to median, this probability is greater than equal to half, and it's less than equal to this median is also greater than equal to half. And the variance is nothing but like if this is the mu, then the spread about mu, a metric for this spread is this variance, and which is given by summation of xi minus mu whole square into probability of x equal to xi, and which can also be simplified as expectation of x square, which is nothing but expectation of gx, where gx is x square, minus expectation of x, and together it's whole square. So these formulas were discussed. And also, as I said, we discussed what we mean by a Bernoulli trial. So Bernoulli trial is a variable with binary outcomes, 0 or 1. Could you please record the session, ma'am? Yes, the sessions will be recorded and it will be shared to you by the NPTEL team. So please wait for them to share the recordings. Okay. So as I said, Bernoulli trial is a Bernoulli variable is a variable which has binary outcomes, yes, no, or 1, 0 kind of a situation. And a binomial is actually a sum of Bernoulli trials, and it can take on variables like from 0 to up to n. And the mass function is nothing but ncx p to the power x 1 minus p to the power n minus x, where x can take values 0, 1 to n, and p is the success probability which can be between 0 and 1. mean of a binomial, it's NP, variance is NPQ, and standard deviation is nothing but root over variance NPQ. So what is Q? Q is 1 minus P. Okay, and then we also discussed what do we mean by Poisson distribution and in scenarios where it is used. So this is also countable, the values can be countable 0, 1, 2, but it could go on till infinity. There is no bound to it, and mostly used to model rare events, occurrences, and so on. So if you can you tell me what is the PMF of a Poisson distribution? Anybody? Well, lambda is the mean, and x can take values between 0, 1, 2, and so on and so forth. So these were discussed, and in terms of a continuous random variable, what we mean by a probability density function, that was discussed, and also it was what we mean by a cumulative density function, that was also discussed. And then how to compute mean and variance, the same thing. Here it will be, this is the formula, and that is nothing but minus infinity to x fx dx, where fx is the PDF. Okay, and similarly I'll show examples how to calculate mean and variance, and examples of normal and exponential distributions were also provided. Now, as part of properties of PDF is the you can say some sort of equivalent to a PMF, like probability mass function. So this one, fx, the values should be greater than equal to 0, and integral of fx over the entire range of x should be equal to 1. And this is the formula, as I said, of a CDF, and there are 4 properties of CDF. As x tends to minus infinity, the CDF tends to 0. As x tends to plus infinity, CDF is the limit of CDF becomes 1, and this is a non-decreasing function in the sense that if x2 is greater than x1, then the CDF evaluated at x2 will always be greater than equal to CDF evaluated at x1, and this is, if this is differentiable, the first derivative gives the probability density function. And if I have to find out the probability that a continuous random variable lies between these two intervals, so the closed bracket means inclusive of x2, so that means probability x1 strictly less than x, which is less than or equal to x2, which is nothing but the differences of the two of the CDFs evaluated at x2 and x1. So I'll go through examples which will help you understand, and also it was discussed what do we mean by an exponential distribution, the PDF, CDF, mean, variance, and median. So for exponential distribution, please remember, if the parameterization is like this, then all of these will hold in the exact similar fashion. Any doubt?
No, ma'am.
Okay. And also we discussed what do we mean by a normal distribution, how the PDF looks like. So This is the functional form of the PDF, where x can take values from minus infinity to plus infinity. That is the range. It has an infinite range. There are two parameters of this model. So if I write x follows normal mu sigma square, then what I intend, these are the parameters where mu is the mean and sigma square is the square of standard deviations. Okay, this distribution is fairly used in most of the cases, and as we it was also discussed, the thumb rule, the percentage of data falling between mean plus mu plus minus sigma, mu plus minus 2 sigma, these are like empirical flag points which you should keep in mind. Okay.
Ma'am,
Yes.
ma'am, can I ask one question?
Yeah, sure.
Ma'am, is this the functional form for where we get the functional form? Is the 1 by 2 pi sigma is e to the power?
So this was discovered by Gauss, and it was shown that uh, so exactly I don't know how to derive it, but this is a PDF. So if you do minus infinity to plus infinity, you will get this as equal to 1. So if you see the lectures, the concept was plotting a, I mean, initially if you plot a binomial distribution, something like this. So let's say if you have a histogram something like this of a binomial distribution, 1 2 3 4 5 6 7 8, something like this. So as you increase the number of trials, it was approximated by these normal curve. Okay, so I am not sure how exactly this was derived, but this is actually the functional form of a normal distribution that was devised by Gauss.
Okay, thank you, ma'am.
Okay.
Actually, ma'am, is based on some experiments, yes or no?
Yes, it was based on some experiments, but
Okay, okay.
yeah, the details of which I am not very aware of. Okay.
Okay, ma'am. Thank you, ma'am.
Okay, thank you. Okay, and then as I said, approximation of the binomial Poisson, and how we can assume approximate normality and go about doing those calculations. Also, what was discussed was that if x1, x2, xn follow normal independently, or yes, they independently follow normal distribution, then summation would also follow a normal distribution. This concept was briefly touched upon, and then the central limit theorem was also said, where one second. Sorry. So the central limits theorem says that if I have a sequence of random variables, then this is one form of the central limit theorem. So if I have identically distributed uh, variables with mu and sigma square, then x bar minus mu by this thing asymptotically follows a normal 0 1. So in essence, what it means that if I have a large number of random variables, then as n increases, the uh, the limiting distribution of the sample mean will also be close to a I mean a normal distribution. So this was also touched upon. And also we saw two distributions, the names at least, based on some normal distribution. So if I have x1 and x2, if both follow normal 0 1, then x1 square would follow a chi-square 1 distribution. If x1 and x2 are independent, then x1 square plus x2 square follows a chi-square 2 distribution. And an F distribution is nothing. This small thing which I am writing in bracket is nothing but the degrees of freedom, or df. So if I divide chi-square 1 by 1 by chi-square 2 by 2, where this chi-square and this chi-square are independent, then the resulting distribution is an F distribution. So if I have a chi-square n1 distribution and a chi-square distribution n2, then chi-square n1 by n1 divided by chi-square n2 by n2 will give me a chi-square will give me an F distribution with degrees of freedom n1 and n. So this is a little advanced thing, but just keep in mind this one is nothing but square or sum of squares of standard normal distribution, and F is nothing but the ratio of two independent chi-squares where both the chi-squares are divided by their degrees of freedom. Okay, so now I'll just proceed to some of the questions that will help solve week 2 questions, and feel free to participate and ask if there's any doubt in any part of these problems. So the first problem says that we have a bag where there are 2 red, 3 green and 2 blue balls. From this collection, 2 balls are drawn at random. Then what is the probability that none of the balls drawn is blue? Any idea how to go about this question? Anyone?
Yes, ma'am. Can I try?
Yeah, sure. Please.
Ma'am, here it is mentioned that 2 balls are drawn at random. So 2 out of 3 to 5 plus 7. So 7C2 will be total number. What is the probability? None of the balls drawn is blue. So this will be 2C0 divided by 7C2.
Okay, the denominator is right, but the numerator there's a little
Ma'am, can
problem.
I try?
Yeah, sure,
It's
try.
maybe
Ma'am, there is the question is given that we have 2 red, 3 green, and 2 blue balls. So we can total number of balls will be 7, and for the sample space we are taking that number of and the question is to 2 balls are drawn at random. So a number of ways of drawing 2 balls out of 7, that will be our ns. So it will be 7c2, and for the event of drawing 2 balls that none of them is blue, so it will be denoted as a. So we are having 2 red and 3 green, so we will add them. So we are having 5 balls which is not blue, and then we can have 5c2 as our um, event of drawing 2 balls which is none of is blue, and then we can divide ne by ns with like 5c2 divided by 7c2.
Exactly. So total number of
One
balls.
more way.
Yeah, see?
Another way is that we should first find the probability of the drawing a blue ball. 2 blue balls, or we can minus from the 1 minus
Yes.
2C2 upon 7C2 also.
Yes, that is also true. We can do it. So here there are two ways of doing it. Total number of balls which are not blue. So this is my event space. Okay, then 5. Then the probability is 5C2, selecting 2 balls out of the remaining 5. That is the event, by the total all possible scenarios of drawing 2 out of 7 balls, 7C2. This will also give me the answer. Or the probability is 1 minus getting all blue. So that is nothing but 1 minus 2C2 by 7C2. Okay.
Yes.
Okay. So this is nothing, if we just calculate 5 into 4 by 2, 7 into 6 by 2. This is nothing but 20 by 42. 10 upon 21. Okay. So the next one. Same thing. A bag contains 3 red, 6 white and 7 blue balls. So if I have to draw 2 balls from the bag, then what is the probability? So then again, total number of balls is 3 plus 6 plus 7, that is 16. So from 16 I am drawing 2 balls. So this will be in my denominator. And the probability of that one ball is white and the other is blue will be, how many whites are there? 6 whites. So out of 6 I am drawing 1, and independently from the 7 blue balls I am drawing another one. So this will be the answer, 42 by 16 into 15 by 2, 42 by 120. Okay.
Yes, sir.
Okay. So now this is question number 3. So we have to determine the mean and variance of a random variable which has the following probability distribution. Now the first thing that I would like to suggest to you is that before solving any of these problems with a finite number of spaces, just make it a habit to see and find out if at all it is a probability distribution. So how will you ensure that there
We
is
will
no
add the probability distribution.
Yes.
If it comes to equal to 1, then it is
Yes.
prob-
So one more thing is, everything should be greater than equal to 0. There should not be any negative values, because probability can never be negative. It should lie between 0 and 1. So if each of these values should be greater than equal to 0, and if you add everything up, then summation px is 1. So I hope everything here it adds up to 1. Can you please check, someone, if this adds up to 1? Yeah.
Yes, ma'am. It
Okay.
adds up to 1.
So it adds up to 1. There is no mistake or in print. So then we can start. So here they are saying, determine the mean and variance of a random variable x. So mean is nothing but expectation of x, which is nothing but summation of x into probability of x. So how will you do it? X can take on value. So 1 into 0.15 plus 2 into 0.10, and so on and so forth, plus 3 into 0.10, plus 4 into 0.01, and ultimately plus 10 into 0.20. So what are you getting here? Anybody got the result?
Ma'am, 6.18.
6.18. Okay, I got something like 6.56. Anybody got 6.56?
Six 6.18.
6.18. Okay, then I must have done some mistake.
Yes, ma'am. I also got 6.1.
Okay, I'll just cross check. Just give me a minute. Plus 9 and 6.18. Okay. Sorry. 6.18. Okay. So this is the mean of the distribution. Now, if I have to find the variance, there are two ways of finding out the variance of x. One is summation x minus this one 6.18 whole square into px. But this calculation becomes very difficult and tedious. Make a table, calculate each difference from 6.18, square it up, and then again multiply. So this becomes a very, very tedious job. So what we'll do in such situations, we'll use the alternate formula, that variance of x is expectation of x square minus expectation of x whole square. So this part we already know, this is 6.18. We just need to compute this part, expectation of x square. So if you remember, expectation of gx was nothing but summation gx into probability of x over all values of x. So here gx is nothing but x square. So this part, expectation of x square, will be 1 square into 0.15 plus 2 square into 0.10 plus dot 10 square into 0.20. So calculate this one and see what you are getting. Anybody got?
Ma'am, once.
50.38.
Okay. 50.38. Anybody else who got this number? Raised a hand. Yes, Mr. Panju. You have a question?
Yes, ma'am. At 50.3.
You got 50.38. Okay. Mr. Panju Sai Kumar, he raised.
Yeah.
Yeah.
Yes, ma'am. I also got the same.
You also got the same. Okay, fine. Fine. So then expectation of x squared is this one.
Final answer is 12.18. Variances.
Yes, the
12.18.
variance is nothing but this one, 50.38 minus 6.18 square, which is 12 point, what did you get?
12.18.
12.18. Everybody got this answer? Hmm. 1876, something like this. So 19. Okay, so this is how, if you are given a probability distribution, first determine whether at all it's a probability distribution, and if it is, then find out mean and variance using these formulas. Okay, so I'll just move on to the next one. Yes. Okay, Mr. Pankaj Kaushik. Very late last time. Okay, so I think the recordings will be available, but the NPTEL team will circulate the recordings. I don't have the permission, so just put a mail to them and these will be made available to you. Okay, but try to join it in time if possible. Okay, thank you. So as I was saying, let's move on to question number 4. So a fair die is thrown, find out the expected values of its outcomes. So what are the outcomes of one throw of a fair die?
1/6.
Outcomes. What can you get? Result. Yes. 1, 2, 3, 4, 5, 6. So this is the outcome. And probability x associated with any of these is 1/6 because it's a fair die. For all x equal to 1, 2, 3, 4, 5, 6. So the expected value of its outcomes is nothing but expectation of x, which is nothing, summation, this one. So this is nothing but 1 into 1/6 plus 2 into 1/6 plus 3 into 1/6 plus 4 into 1/6 plus 5 into 1/6 plus 6 into 1/6. So we'll just take 1/6 common. 1 plus 2 plus 3 plus 4 plus 5 plus 6. This will be 1/6 into n into n plus 1 by 2, which is 3.5. Is it clear?
Yes, ma'am.
Anybody? Any doubt? Okay. So I'll move on to question number 5. So here we have been given probability mass function of a discrete random variable. And we have to find the value of expectation 3x plus 2x square. So as a first check, is this a probability mass function? Yes, because it is adding up to 1.
1.
Okay, so in order to solve this one, what we need is that expectation of 3x plus 2x square This one is nothing but 3 into expectation of x plus 2 into expectation of x square. Expectation of ax plus b is nothing but e of expectation of x plus b. So similarly, expectation of ax plus by would be a of expectation of x plus b of expectation of y. So following suit, this is what we have. Now we just need to compute expectation of x and expectation of x square. So expectation of x is 0 into 0 0.2, 1 into 0 0.1, 2 into 0 0.4, 3 into 0 0.3, 0 0.1, 0 0.8, 0 0.9, 1.8. And expectation of x square is 0 square into 0.2 plus 1 square into 0.1 plus 2 square into 0.4 plus 3 square into 0.3. So this comes out as this I'm getting as 4.4. So substituting the values here, we have 3 into 1.8 plus 2 into 4.4. 5.4 plus 8.8 to 13.2 is the answer. Sorry, not 13, 14.2. Is it fine? All of you got these two answers?
I'm solving just 2 minutes.
Okay.
Ma'am, ex square is 4.32.
4.32?
Yeah.
Okay. I'm getting 4.4.
Ma'am, I'm getting 3.6.
How? This one, it's fairly simple. 0
Ex
square,
square.
this is 0. 1 into 0.1, that is 0.1. 2 square is 4 into 0.4, that is 1.6.
I made some mistake.
And this is 9 into 0.3, that is 2.7. I think you should get 4.4.
4.2.
4.2 or 4.4?
No, 14. Answer 14.2.
Answer is 14.2. Yes.
14.2.
Yeah. Okay. So you got how to solve this one. Now, as an additional tag question, if I ask you what is the variance of 3x plus 2? Then how are you going to solve this one? So for variance, the formula is variance of ax plus b is a square variance of x. So it is affected by scale. If there is a scaling parameter, something multiplied or divided, then that is affected. But translationally, variance is not affected. So here, if I have to find out expectation of 3x something plus 2, it will be 3 of expectation of x plus 2. But variance of 3x plus 2 will be 9 into variance of x. And you know how to compute variance of x is expectation of x square minus expectation of x whole square. Okay, this is one point that I want to tell you. Okay, but if so, where a and b are all scalars, okay, not some random variable. But if there's another random variable like or some functional form involved, then you would have additional terms also. But just remember this part, okay? Variance of something, some 3x plus 5 will be 9 variance of x. So for this question, if I have to find out variance of 3x plus 2, I would have to the answer would be 9 into variance of x, and variance of x is this one expectation of. So coming back to the question, expectation of x square was 4.4, expectation of x was 1.8. So variance of x would be 4.4 minus 1.8 square. So it would be something like 1.16. Okay, and another thing that you should be very sure of is variance cannot be negative. Rarely it is 0 if there is no variation in the data set, but this should always be greater than equal to 0. Variance should not be negative. If this comes negative, then there is some problem in your calculations. Okay, just bear this in mind.
Now, what is the formula for this? That variance of ax square plus b.
Yeah, variance of ax square plus b is a square into variance of x. Okay, so that's what I'm saying. If there is a scale change, something is multiplied with x, that thing will get squared, but plus or minus will remain unaffected. So variance of 3x plus 5 is also 9 variance of x. Variance of 3x plus 7 is also 9 variance of x. Okay.
My question is, if it is a 3x square, then what will happen?
Oh, variance of 3x square. If you have variance of 3x square, then it would become 9 variance of x square.
Okay.
Then it becomes 9 expectation of x squared square, that is expected x to the power 4 minus expectation x square, this one whole square.
Okay.
Okay.
Okay, thank you.
Okay. So moving on, let's find this one. This is a continuous random variable with probability density function. So one check if it is a density function is, we know minus infinity to infinity fx should be 1 if fx is a density. Now this function takes values of 4x cube only between 0 to 1, otherwise it's 0. So if we split the intervals, we'll get this one is the same as 0 to 1 4x cube dx, right? So this is nothing but 4x to the power 4 by 4, 0 to 1, which is 1. So this is a PDF. This check is done. Okay. So if in the context of a continuous random variable, if I have to find expectation of x, that is nothing but integration x into fx dx, x ranging from the entire minus infinity to plus infinity. So here, if you see, from minus infinity to 0, the value of x is 0. So the entire thing is 0. From 1 to plus infinity, again fx value is 0. So what remains is, right, this one is equivalent to 0 to 1 x into 4x cube dx. This is nothing but 4x to the power 4 dx, which is 4x to the power 5 by 5, 0 to 1, which is 4 by 5. Similarly, if I have to find variance of x, I need to find out expectation of x square minus expectation of x whole square. This part I know. So expectation of x square is integration x square into fx dx minus infinity to infinity, which is nothing but 0 to 1 x square into 4x cube dx. I'll draw it in another one. So variance of x, expectation of x square minus expectation of x whole square. Expectation of x square is 0 to 1 x square 4x cube dx, which is 0 to 1 4x to the power 5 dx, which is 4x to the power 6 by 6, ranging from 0 to 1. This is 4 by 6 or 2 by 3. So then variance of x becomes expectation of x square, that is 2 by 3, minus expectation of x, which was 4 by 5 whole square, 2 by 3 minus 16 by 25. This is the answer. Is it clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So moving on. Here they are saying two unbiased dice are thrown. Find the expected values of the sum of numbers of points on them. So let x1 be outcome on die 1, x2 be outcome on die 2. So they are asking expected value of the sum of numbers of points on them. So as I was saying, expectation of x1 plus expectation of x2 is expectation of x1 plus expectation of x2. So x1 can have values like the previous one, 1, 2, up to 6 with equal probability, 1 by 6. So this one, expectation of x1 was nothing but 1 into 1 by 6 plus 6 into 1 by 6 that we did a few problems back. So this one, for this one also it's the same, 1 into 1 by 6 plus 6 into 1 by 6. So this came out to be 3.5 plus 3.5, total is 7. Okay. Now if instead of expectation we have if we have variance, then this can be written as variance of x1 plus variance of x2 only if x1 and x2 are independent, not always. So this one is not always equal to this thing. So just keep this in mind. Not always true. So as I was saying, I'll put it in a separate slide so that it's so variance, one second, variance of x1 plus x2 not always equal to variance of x1 plus variance of x2. Okay, this does not hold always, but this will always hold. x1 plus x2 equal to expectation of x1 plus expectation of x2. This holds. Okay, moving on. Here we have another thing. So here we have been given a probability density function fx, which is denoted by y here, equal to k x minus 1 into 2 minus x, where 1 less than equal to x less than equal to 2, and if nothing is mentioned it means 0 otherwise. So we have to determine the value of constant k.
Ma'am, we can integrate the fx value, that k
Yes,
x minus 1 to.
exactly, that
And
is what we are going to do. So we'll just take the value range of x where this function takes some functional form, that is 1 to 2, k into x minus 1, 2 minus x, this should be equal to 1. So we'll solve this equation. K 2x minus x square minus 2 plus x. X 3x minus x square minus 2 dx equal to 1. So k I'll take outside. This one is 3x square by 2 minus x cubed by 3 minus 2x. 1 to 2 equal to 1. So then substituting 2 here, 3 into 4 by 2 minus 8 by 3 minus 4 minus 3 by 2 minus 1 by 3 minus 2. So it implies k by 6 equal to 1, and then k is 6. This is the answer. Everybody got it?
Yes, ma'am.
Okay. So we'll proceed to the next one. Here again, it has been said that the time to failure is modeled as it has a density function of this functional form. Determine the constant k and find the expected life and median life. Expected life and median life. So if you look carefully, this looks like an exponential distribution. But we'll just confirm whether it is an exponential distribution or not. Okay, so how we'll do it? 0 to infinity k e to the power minus 3x should be 1. 0 to infinity e to the power minus 3x dx should be equal to 1. 0 to infinity should be 1. K, putting infinity over here, this becomes 0, minus of this is 1 plus k by 3 equal to 1, which is k equals to 3. So putting k equal to 3, we have so this is an this looks similar to an exponential distribution. If you remember this functional form. Now yes, so this is an exponential distribution. We have to find out the mean and median. So if you expectation of x is x into fx dx 0 to infinity. So then x 3 e to the power minus 3x dx 0 to infinity. Okay. So 3 we can take out. 3 we can take it here and this thing. So if you remember the rule, integration of u into v. So solving this is nothing but this thing. So
Ma'am,
x, yes.
ma'am, in the second line, the x is the probability, isn't it?
No, x is the value.
Ma'am,
Which second line?
This x is
Is the value of the function. And this k times e to the power minus 3x, this in some way is the probability density. So what we mean to say is that if there's, let's suppose this is the function, this is a point x, so around, if we take a very short, very small interval, this area which I am shading, that is k e to the power minus 3x. X is actual value of the function. Here, this is x, and these things is, this is the graph of this 3 to the power minus 3x. So x here is not the probability, it is actually the time to failure. That is x. Is it clear?
yes, ma'am. Yes.
Okay. So here we just have to use simple integration formula, x into integration v dx minus d dx of x, integration this one dx, whole thing should be evaluated from 0 to infinity. So if you solve this one, you will get 3 into x e to the power minus 3x by minus 3 minus integration of e to the power minus 3x dx by minus 3, 0 to infinity. So I'll just do it here, which is nothing but 3 x e to the power minus 3x by minus 3 minus of, sorry, plus of 1 by 3 e to the power minus 3x dx, 0 to infinity, 3 x e to the power minus 3x by minus 3 minus 1 by 9 e to the power minus 3x dx, sorry, the power minus 3x, 0 to infinity. So if you evaluate putting infinity here, we are going to get 3 into 0 minus 0, and putting 0 over here we'll get 0 minus 1 by 9. So this is 3 by 9 or 1 by 3. So if you just tally, if you have an exponential distribution of this functional form, then expectation of x you'll find in slide given by 1 by lambda. So here lambda is nothing but 3, so mean will be 1 by 3, and that is what we got. Is it fine? And also they have asked for the median. Median of an exponential distribution is ln2 by lambda. So here our lambda is 3, so median time will be this by 3, whatever value we get here. Ln means log with base e, not 10, okay? So this will be something like 0.23, the answer. ln2 is 0.693 by 3, this will be 0.23. And ln2 means log 2 base e, natural logarithm. Okay? Any doubt so far? I got 4.4. Okay. Fine. Moving on. This one. So, number of calls in a customer help center, this is usually modeled using a Poinsot distribution, because it could be 0, 1, 2 and infinite. Okay, so we assume that let x, the random variable, be number of calls every hour. So here we have the information. We are assuming, let us assume x follows Poinsot distribution with mean lambda, where lambda is nothing but average, the mean. This lambda parameter is nothing but mean of the Poinsot distribution. Now for a Poinsot distribution, expectation is also lambda, variance is also lambda. Just keep this in mind. So here lambda is 3.5. Now what was the probability mass function of a Poisson distribution? This is e to the power minus lambda, lambda to the power x by x factorial. X could be 0, 1, 2 and so on. So here what they have asked is, what is the probability that it will receive at most 4 calls. At most means not more than 4. So this one is probability x less than equal to 4, which is nothing but sum of 0 calls, 1 call, 2 calls, 3 calls and 4 calls. At most, it will not go beyond. So if we have something like this, how are we going to calculate? So probability x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4. So we'll just substitute the value of x in the mass function. So what we'll get? E to the power minus 3.5, 3.5 to the power 0 by 0 factorial, plus e to the power minus 3.5, 3.5 to the power 1 by 1 factorial, so on, plus e to the power minus 3.5, 3.5 to the power 4 by 4 factorial. Somebody is facing problem. Can the others see my screen?
Yes, ma'am.
Okay. Then Miss Anupama, I think there's some problem in your end. Just try to figure out, because it seems everybody else can see the screen. You can log out and log in again. Not an issue. Okay. Yeah. So the question is, yes, this was the question. A customer help center receives on an average 3.5 calls every hour. So the mean number of calls per hour is 3.5, and the probability, we have to calculate what is the probability that it will receive at most 4 calls every hour. So at most 4 calls means 0 calls or 1 call or 2 call or 3 call or 4 calls. Not more than that. So how will we calculate? Yes.
We use Poisson here because of that lambda expectation of x is equal to. That means that mean is same. That's why.
Exactly.
Okay. Thank you, ma'am.
the mean remains same. Okay, so after this one, we'll just we'll put the values of x here and then calculate. So I think you should get this to be something around 0.72. You can check. Anybody got this thing? 0.7254. Anybody got this? Not yet. Okay, so you will get something like this. Uh, Nobody got till now? Alright, I'll just move on. You'll get something similar. This is how you should calculate. So the next question is, what is the probability that it will receive at least 5 calls every hour? Previous one was at least, at most 4. So this is at least 5, that is x should be greater than or equal to 5. Now if I have to calculate this one, this will be x equal to 5 plus x equal to 6, and there is no end to it. Or equivalently, what we can do is, this can be 1 minus probability x less than equal to 4. And this is what we have calculated in the previous step. So it will be 1 minus 0.7254, which is 0.2746, and this is the answer. Is it clear? Am I audible?
Yes, I'm clear.
Oh, okay. Okay, so I'll just move on to the next one. Now the next question is similar, but there's a subtle difference. So here a person receives on average 3 emails per hour. So as someone rightly pointed out, this average remains same. So and this number of emails can take on any values. So here also we are going to assume a Poisson distribution. Now what will my random variable be? My random variable will be based on the question that is being asked. So here a person receives on average 3 emails per hour. I have been asked to find out what is the probability he will receive 5 emails over a period of 2 hours. So the random variable here is number of emails received in 2 hours. So then the lambda, that is average number of emails received in 2 hours, will be 3 into 2, because 3 emails per hour. So in 2 hours on an average we are expecting 6 emails. So with lambda equal to 6, not 3, we are going to proceed with our calculations. So the same thing, what is the probability he will receive 5 emails over a period of 2 hours is probability x equal to 5. That is nothing but e to the power minus 6, 6 to the power 5 by 5 factorial, whatever this comes. And the next question, what is the probability he will receive more than 2 emails over a period of 2 hours? This is probability x more than 2, greater than 2, which is nothing but 1 minus probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. So again similarly we are going to calculate. This will be 1 minus e to the power minus 6 6 to the power 0 by 0 factorial plus e to the power minus 6 6 to the power 1 by 1 factorial e to the power minus 6 6 to the power 2 by 2 factorial. Whatever we get, we'll subtract it from 1, and the final answer should be something around 0.93803. Is it clear what is the difference between the first one and the second one? So here we were given an average of every hour, and the question was also what is the variable was also defined for every hour. But here, since the focus is not on each hour, it's on 2 hours, the variable has been defined in such a way we have to modify the lambda according to the definition of our variable. This is the point that I wanted you to understand. It's fine, right?
Yes.
So if the question was over a period of 30 minutes, then lambda would have become 1.5. Okay. The next one. This one, sorry. So here mass produced needles are packed in boxes of 1000. It is believed that one needle in 2000 on average is substandard. So let us define x, our random variable, as number of defectives in 1000 samples. So probability of each needle being defective, let us denote it by P, is 1 by 2000. So number of detectives in 1000 sample, this follows a binomial 1000 P, where P is the success probability or probability of defective. So then probability not defective, it will be 1 minus P, which is 1999 by 2000. So here we have been asked what is the probability that a box contains 2 or more defectives. So we have been asked to find out probability x greater than equal to 2. So this one is same as 1 minus probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. Sorry, greater than equal to 2. So it means, just a second, I'm really sorry. Probability greater than equal to 2 means 2 is included. So if I have to get the complementary set, then this means 1 minus probability x less than 2, which is 1 minus probability x equal to 0 plus probability x equal to 1. And how am I going to calculate probability x equal to 0? Probability x equal to 0 is, this is n and this is p. So n cx p to the power 0 x q to the power n minus x, which is nothing but 1999 by 2000 to the power 1000. Clear? And similarly, probability x equal to 1 will be 1000 C1 p to the power x into q to the power 1000 minus x. So after because binomial probability is ncx p to the power x 1 minus p to the power n minus x. This formula we have used. So using this we got P probability x equal to 0. Also we got probability x equal to 1. So required probability x greater than equal to 2 is 1 minus probability x equal to 0 minus probability x equal to 1. And if you do all calculations, then this will come to 0.0902, something like this. Okay. Is it clear how you should go about the calculations? Any doubt?
No one.
Okay. So moving on. So entry to a certain university is determined by a test. Scores on this test are normally distributed, where this is mean and this is standard deviation. Now Tom wants to be admitted and he knows that he must score better than at least 70% of the students who took the test. So he takes the test, scores 585. Will he be admitted to the university? This is the question. So X is marks, or rather score of a student. X follows normal 500, this one, and 100 square is its variance. Now probability x less than 585 is nothing but actually proportion of students who have scored below 585. Is this fine? Now this thing can be, I have to find out this probability. So instead of doing this, I can always transform it to a standard normal thing. So how do I standardize? I'll subtract by mean and divide by the standard deviation. So this is mean, this is sigma square. This can be written as 585 minus 500 by 100. Okay, so now this one, this variable, it follows a standard normal distribution, and this is less than 0.85. So this one we'll get the probability value from the table. So here we see z less than 0.85. So first we'll go to the first decimal. This is first decimal, this is second decimal, and the table values, they represent probability, like this one represents probability z less than equal to 0.09. Okay, this is the scheme. So here I have to find out probability that the standard normal variable is less than 0.85. So I'll go here, I'll find out 0.8 and then move 2 decimal places, this one, 0.8023. So this one is 0.8023. So what it means is that if I have to interpret, 80% of total students approximately have scored less than Tom. So in other words, he has scored better than 80% of the students, and he had to score better than 70%. That was the criteria. So the answer is yes, he'll be admitted. Any doubt? So he had to score better than 70% of the students who took the test. Now this proportion x less than 585 is 80.23, which means that 80% of students have scored less than Tom. Or in other words, Tom has scored better than 80% of the total students. The total area of this curve, of this normal curve, let's say it's 1, and the area represents the proportion of students who have taken the test. So this one, since it is 80.23, it's greater than 70, so the answer is yes, he'll be admitted to the university. Is it okay? Can I proceed? Am I not audible? Hello?
Ma'am, you're audible and visible, clear.
Oh, okay. Fine. So then I'll just move on to the next one. Okay. So here also we have mean weight of 500 students is 151 pounds and standard deviation is 15. So if the weight is normally distributed, then find how many student weights lie between 150 and 155. So x is the random variable denoting weight of a randomly selected student in pounds. So we have to find out probability 120 less than equal to x less than equal to 155. So instead of doing the calculations with x, since we have the table for a standard normal distribution, we'll do this formula x minus mu by sigma. We'll just transform. So here mu is 151 and sigma is 15. So this is same as 120 minus 151 by 15 less than equal to x minus mu by sigma 155 minus 151 by 15. So this is minus 31 by 15 less than equal to z less than equal to 4 by 15, where z follows a standard normal distribution. So this one, if we calculate, we'll get probability minus 2.07 less than z less than 0.27. This one can be written as, so we want to find out, let this point be this thing. So we want to find out this area, let's say. So instead of doing this, we can do one thing. We can just calculate the area till this point and then subtract this much area from the entire thing. So this will be probability x less than equal to 0.27. This one is probability x less than equal to minus 2.07. So if we just do a subtraction, we'll get whatever is between this thing. Fine. So here we are writing it like this. And since it's a continuous variable, we can also put equal, it doesn't matter. Less than equal to minus 2.07. This is probability x less than equal to 0.27, and since, sorry, this will be will not be x, this will be z. 1 second. Okay. Now, if you remember, the table will not have any negative values. So if I have to convert this one, this is, let's suppose, this is the distribution of a standard normal distribution where mean is 0. So probability something is less than minus a means this area. So this one is the same thing as if the total area 1 minus probability x less than equal to a, this area, because essentially this shaded part is equal to this shaded part. So this one is nothing but 1 minus probability x less than equal to a total minus whatever we have. So since this is symmetric about 0, we can write this probability z less than equal to minus 2.07 as 1 minus probability z less than equal to plus 2.07. So from the table, we'll see, first we'll determine the value. So we need two values, probability x less than equal to 0.27 and probability x less than equal to 2.07. These two values we need. So less than 0.27 means 0.2, then we are going to 7, this one. This is 0.6064. Less than 2.07 means 2.07. That is 0.9808. So the required answer was probability x less than equal to 0.27 minus 1 minus probability x less than equal to 2.07. So this is nothing but 0.6064 minus 1 plus 0.9808. So this will come around something as 0.5872. That is the probability of x lying between these two ranges, 151 and 120 and 155. 120 and 155. But if you look carefully at the question asks how many students weigh. So that was the probability or the proportion. So the answer, number of students, approximately we'll get it by multiplying this probability with the total number of students, 500. So if we do that, we'll get it something around 294 approx. So the final answer is 294 students have weights between 120 and 155 lbs. Any doubt here? Is it clear to all?
Yes, ma'am. Clear.
Okay. So moving on. So another easy question. 2 defective light bulbs are mixed with 8 non-defective light bulbs and a sample of 3 tube lights are taken at random. So total bulbs 2 plus 8, 10. From these 10, 3 tubes are selected at random. So total number of ways in which it can be selected is 10C3. And what is the probability that both defective tube lights are selected in the sample? So we have 2 defective, 8 non-defectives. So both are selected. So they can be selected in only one way or 2C2 ways. So given these 2 are already selected, we just need to select one more. So that one should be selected from out of these 8 non-defective ways in this manner. So this is nothing but 8 by 120, which is 1 by 15. Moving on. So here, if you read the question, laptop cooling systems are controlled by electrically driven fans. Assuming that the lifetime T in hours can be modeled by an exponential distribution with lambda this thing, find the proportion of fans which will give at least 10,000 hours of service. So X is the lifetime of the fan, of a randomly selected fan. X follows exponential with lambda 0.0003. So fx is nothing but lambda e to the power minus lambda x if x greater than 0 and 0 otherwise. Now we have to find out that proportion of fans which will give at least 10,000 hours of service, or in other words we have to find out the probability that the lifetime would exceed 10,000. So how will I go about doing this? This is nothing but 10,000 to infinity lambda e to the power minus lambda x dx. So I'll take lambda out, 10,000 lambda e to the power lambda x dx. So it will be lambda e to the power minus lambda x by minus lambda 10,000 to infinity. So that is the lambdas will cancel, e to the power minus lambda x 10,000 to infinity. So putting infinity here we'll get 0 minus minus of e to the power minus lambda into 10,000 to the power minus lambda into 10,000. Now lambda is 3 into, so this one if we put minus 0.0003 into 10,000, then we'll get e to the power minus 3. So e to the power minus 3, the e to the power minus 3 is something around 0.0498. So approximately 0.05. So what it means is that 5% of the fans, this is the proportion of fans which will have a lifetime greater than 10,000. So if it is the answer, proportion of fans which will at least give 10,000 hours of service approximated to the nearest degree is, the answer is 5%. Is it fine?
Fine.
Okay. Moving on. So overbooking of passengers is a common practice. An aircraft capable of carrying 300 passengers booked to carry 320 passengers. On an average, 10% of the passengers who have booked, they fail to turn up for their flight. So then what is the probability that at least one passenger who has booked will end up without a seat on a particular flight? So let X denote the number of passengers who booked and turned up. So X can be, it follows binomial 320p, where p is the probability of booking and also turning up. Probability of booked and turn up, which is 1 minus probability booked but did not turn up. This is 1 minus 10%. It is 0.9. So 1 minus P or Q is 0.1. Now, since this is a large number, 320, this binomial distribution can be approximated by the normal distribution. Okay, so for that, what we need to do, we will see if at all it can be converted to a normal distribution. So we'll find out the mean of this binomial distribution, which is NP, which is 320 into 0.9, that is 288, which is greater than 10, and the variance NPQ equal to 320 into 0.9 into 0.1, which is also greater than equal to 10. So based on those two criteria, we can go for a normal approximation. So if we have to go for a normal approximation, and we have to find out that at least one passenger who has booking will end up without a seat. So that means the total capacity of the flight is 300. There has been 320 bookings. So the probability number of booked and has turned up to be greater than equal to 301. Correct? Now using that continuity criterion, we can write probability x strictly greater than 301 minus 0.5, that is 300.5. This one we can write as x minus mu or np by root over npq greater than 300.5 minus what was our mean, 288, divided by square root of npq. 332 into 0.9, it was how much? So root over 28.8. Okay. So this one is approximately a standard normal distribution greater than, this part will come out as 2.33. This is the approximation by CLT that we are doing. As n increases, x minus mean by root over standard deviation, root over variance will tend to a standard normal distribution. So this one is nothing but probability z less than equal to 2.33, and from the table 2.3 and again 3 is 0.9901. So this is 1 minus 0.9901, which is nothing but 0.0099. That's the final answer. Is it clear? I hope this is clear with you.
Yes, ma'am.
So the last question for the day, similar sort of questions. In a given sample of 100, 27 are found to be blue, but according to this company 24% candies are blue. So we have to find, assuming this is correct, we have to find the probability that probability of randomly selecting 100 and getting 27 or more that are blue. So the random variable is number of blue candies. This follows binomial 100 and p, where p is the claimed rate, that is 0.24. So we have to find out the probability getting 27 or more that are blue. Probability x greater than equal to 27. So applying continuity correction, probability x greater than 26.5. Here again, if I have to do a normal approximation, NP is 24 and NPQ is 24 into 1 minus 0.24, which is also quite greater than 10. So this one can be then written as z greater than 26.5 minus 24 by square root of 24 into 1 minus 0.24. So this will come as probability z greater than 0.5854, which is nothing but 1 minus probability z less than equal to 0.59, let's say, what we have. So if we go back to the table, 0.5 and 9 is this value, 0.7224. So this, the answer is 1 minus 0.7224, which is nothing but 0.2776. That's the answer. Okay. Any doubt?
No, ma'am.
Okay. So that was all from my side for today. If you do have any doubt, please ask me, or you can post it also in the discussion forum, and I'll try to address it. And please try to join next week and get your doubts cleared. Anything else anybody wants to say?
I mean something practicing for practice.
For practice.
Yeah.
Okay, so a few of the textbooks have been referred to in the course content. You can go through the exercises of those books, and also you can just look up on the net based on the course content or the topics. You'll get ample questions and solved examples, but it's better if you follow the reference books that have been given.
Okay, madam.
Okay. If not anything, then I'll close the session. Thank you for joining.
Okay, thank you.
Okay,
Thank you,
the
ma'am.
subject is
Thank
new.
you, ma'am.
Thank you. Kamal Konkati says that this subject is new to me. Can you suggest something how to start? Okay, Kamal, you can, as I said, there have been a few reference texts which have been mentioned in the lectures. You try to go through, if PDF or some, try to get hold of those books and follow. Otherwise, you can also follow YouTube lectures. Just Google and you'll get ample content online. And if you face any doubt, you can always post in the discussion forum and we can get that cleared. Okay, so I'll just stop the session. Thank you for joining. I'll see you next week. Bye bye.
Thank you, madam. Good night.
Thank you. Good night.